planet, there are basically two different kinds of mountains. One kind of mountain we've talked about extensively, it's a volcanic mountain. Volcanic mountains form when a little bit of lava erupts, and when that lava erupts, it cools into igneous rock. By building layer upon layer upon layer, eventually it forms a big pile, piles that could be sometimes miles high, and we call that a mountain. The other kind of mountain is a non-volcanic mountain, and we call that mountain a folded mountain. These kinds of mountains show up at plate boundaries, and specifically ones where they're moving together. Because when these plates can move together, one piece of crust and another piece of crust have nowhere to go. And they'll fold on top of each other, forming a mountain. A good way to think about this is with a piece of aluminum foil. Similar to the crust, the aluminum foil is very thin, just like the crust. It's solid, and just like the crust, it is also way flexible, more than we would expect. When we think about the crust, we think about rock, and we think it's huge because we're thinking about it as us. But in the context of the amount of time on Earth, and Earth is very old, the crust has actually changed shape quite a bit. And aluminum foil does the same thing. If I were to move this aluminum foil towards itself, together like this, converging it, eventually the crust has to go somewhere, and it folds up to make a mountain. Here's a bird's eye view of that mountain range. You can see this giant peak up here. Whoa! Imagine yourself as a tiny mountain climber at the base of the mountain, moving slowly up the slope. Oh no, an avalanche. Oh no, snowstorm. Oh no, ice wolves. I don't know what an ice wolf is. Finally, you've reached the top. Now, this happens on the scale of the Earth in a massive, massive way, producing mountains that can be sometimes 5,000, 10,000 feet tall. That, of course, takes a long time, millions of years. Our tallest mountain range, Mount Everest, is one of the fastest growing mountain ranges. We can actually measure how quickly it's growing each year because the two plates are moving together so quickly that it's pushing the mountains up so high. I'm a big fan of old maps, and behind me is an old map of India. Now, it doesn't look anything like India. You just see this weird pink blob. It was made by people who didn't really know the world very well, because back in the day, a lot of people were sailing around the edges of it and not able to figure out what it looked like from like a satellite or something. But one thing that's interesting about this map of India is that very clearly predicted are these mountains between India and China. If you look really closely, you might be able to see them right here. Those mountains are the Himalayan mountains, and the Himalayan mountains are some of the tallest in the world. They're right between India and China, and they're actually very new as far as mountains go, just a couple 100 million years old. Pretty young. The reason that the mountains are so spectacular compared to other mountain ranges is that they are growing really quickly, at a point where we can actually measure how quickly they're growing. Another thing that's weird about them is that you can find these rocks in them. This is Himalayan pink salt. You may have heard of this because a lot of people are really into this bougie salt right now. Tastes a lot like any other kind of salt. There's not really anything else to it, but it has this nice pink color because of the deposits that it's in. These get mined in an area of northern India called the Salt Range. It's a mountain range that's pretty rich with this rock salt that's here. And these salt deposits actually are from an ancient ocean. Well, it's the top of a mountain. Where would there be an ocean? Long time ago, there was a massive ocean, and India was basically a microcontinent like Australia, almost an island. Well, India is on a plate that was converging towards where China is now. As that plate converged, it ended up shrinking the ocean that was there, pushing it out of the way as two continents collided. Once those continents collided, they were touching. There was nowhere for the land to go but up and down. One of those plates was pushing downwards back into the mantle, melting back into magma, and the other one was pushing up, creating the folded mountains that are now the Himalayan mountains. They're still pushing together even now, as forces underneath them in the mantle are driving them together with the rolling force of convection. Here's a bit of a better map, although pretty similar colors. India is in pink over here, and China is in green. And then the country Nepal is right over where the Himalayas are. That's in green in between them. So at one point, India was actually all the way down here in the Indian Ocean. But it started moving upwards until it collided with China. That took a number, like almost 300 million years. This was in the Jurassic area when dinosaurs were around, that India was all on its own. But once it pushed up, it pushed the entire ocean that was there up with it, leaving behind the salt. It's actually pretty good, so that we could mine it and use it in our food. Now, as these two plates push together, eventually they kind of run out of room to go up. One of them has to get pushed down. Each plate is always going to be a little bit different from the other plate. One plate, no matter what, will always be a little bit more dense, and dense things tend to sink. So when the two collide, whichever one happens to be more dense will subduct down. Now, when two continents collide, we can't really tell which one is the more dense one and which one's subducting unless we look for something called a plateau. Plateaus are flat areas that are a little bit higher, and because they're raised up, we can tell that's the plate that's getting uplifted. The side that doesn't have a plateau must be going underground. And so geologists can tell out of a convergent plate boundary which one is going back into the mantle and which one is not. Obviously, you can't tell this aluminum foil, so we'll just look underneath and see that this plate is getting pushed under this plate here. So this plate is subducting. I'm kind of cheating because I can see this. It doesn't make caves or anything. Instead, the mountain just folds back over it as if there was never any subducting happening at all.